All right, let's take a crack here at lesson 4-5. Solve that rational equation. So let's see, this denominator right here looks like you could factor it into z plus 5, z minus 3. Yep, and then multiply the whole equation is my preferred way. There's a couple other ways to explain these. So if you don't get it and you want to message me to see if I can help you, let me know. Multiply everything by those common denominators to get rid of all the fractions. It's the fractions and the denominators that make this a problem that have the variables. So if I multiply each one of these by that, I'm going to end up getting rid of all of those denominators. So if I multiply it over here times this first fraction, the whole thing there divides out with this whole denominator, leaving just the z plus 1. Then when I move on to multiplying it, I got to multiply everything on both sides. So when I multiply it here, the z plus 5s are going to go away. I'm going to have this z times the z minus 3. And then I'm going to multiply the last one as well. So when I multiply times this last fraction, I've got a minus here. And then the z minus 3s are going to go away, leaving the 1 times the z plus 5. Now we just are going to have a quadratic equation. We've gotten rid of all the fractions or the denominators, so we should be able to solve this. So we've got my z plus 1. Z times z, z squared, minus 3z, and then distribute this minus. Be careful here. I like to keep this z squared term positive myself, so I'm going to move these both over to that side, giving me the equation z squared. That would have been a negative 4z. Subtract this one also, I've got negative 5z. And I had a negative 1, subtract this one over, that makes it a negative 6. Everything's gone on the left side, so a 0. And then I think this would factor into z minus 6, z plus 1. Check that if you'd like. And then set each factor equal to 0 and undo your operations to solve for your possibilities. Now we always have to double check when we get done that we didn't make the denominator equal 0 or that something actually does work. But I would get the two solutions of 6 or negative 1. And if we go back and look in our problem, neither one of those would make the denominators equal 0. So the correct answer here, right there, and separate them by a comma, and I think we would have it. So that's problem 10. It's those variables in the denominators that make it a problem for solving those equations.